You are aware of hundreds of changes around us. You would have overgrown your clothes many a times. So, growth is a change taking place in you. Seedlings grow into plants, leaves change color and fall off the trees. Wood burns to ashes, rice softens on cooking, ice melts, milk sours, and fruits ripen. You must have noticed many more changes. Some of these changes may be occurring slowly, like the weathering of rocks. Others may be fast, like ice melting into water. Some changes may be desirable, like the making of ice cream. Some may not be desirable, as the souring of milk. Of what use is the ice cream if you have a throat infection? When your mother makes paneer, milk needs to pass through the souring process. So what was desirable in the earlier context becomes undesirable and vice versa. We certainly need an understanding which does not depend on personal likes and dislikes, but on logical reasoning and knowledge. All the changes quoted above are changes in matter.
Plasma. When a gas is heated to many thousands of degrees Celsius, the atoms become charged particles and hence become ionized. These particles show altered properties which has little resemblance to properties of solids, liquids or gases. For example, they become conductors of electricity and are affected by magnetic forces. Matter thus reaches the plasma state.
What is matter? Matter is anything that occupies space and has weight, as against energy like light or electricity, which does not occupy space. Matter can exist as solid, liquid, and gas. At very high temperatures, matter becomes plasma, often considered to be a fourth state of matter. What is matter made up of? Matter is made up of small microscopic particles called atoms and molecules. There is a very large variety of matter because these tiny particles can interact and arrange themselves in countless ways. It is their unique arrangement that gives a matter its unique properties. Matter can be of three types. Matter, element, when matter is made up of just one kind of atoms. Compound, when matter is made up of two or more kind of atoms that is stable and cannot be separated easily. Mixture, when two or more elements and compounds come together but can be easily separated. States of matter. Let us recall from what we have learned in earlier classes that matter exists in three basic forms: solid, liquids, and gases. A solid is rigid and retains its shape and volume. A liquid is fluid, has a definite volume, and will take the shape of its container. Gases, also fluids, have neither a fixed shape nor fixed volume. They fill the shape of the container. Plasma may be described as a gas of free positive and negative ions with almost no overall charge. Ice. Solid molecules are held together by a strong force of attraction. Molecules of a solid maintain a constant position in relation to each other and vibrate about a fixed position. Water. Attraction between liquid molecules is weak, but they are still held together to give liquid a definite volume. The particles vibrate and change their position, so a liquid flows. Steam. There is a very little attraction between gas molecules, it allowing expansion in every direction. The molecules move about randomly and occupy any available space. Matter relates to each other in different ways, depending on affinity. All matter at all times undergo changes, leading to creation and destruction of matter. The arrangement and interaction of these molecules give a substance its physical and chemical properties by which matter can be identified. Matter keeps changing from one state to another as the physical condition like temperature, pressure changes. Let us learn some common terms. Heat. Heat is a form of energy contained in a body which depends on its mass, temperature, and a factor of specific heat. Vaporization or evaporation, a process of conversion of liquid into vapor with or without reaching the boiling point. Our sweat drying on our skin is an example of evaporation. Sublimation, process in which substances can be converted from solid state to gaseous or vapor state without going into the liquid state. These substances again condense to become solid on cooling. Naphthalene is an example. Melting. When a substance changes its state from solid to liquid, it is said to melt. Melting point is a particular temperature when this happens. The solid and the liquid state of the substance are at an equilibrium at this temperature. Freezing. When a substance changes its state from liquid to solid state, freezing point is a particular temperature and may or may not be the same as melting point. Boiling. It is the state for a liquid when the maximum vapor pressure of the liquid is equal to external pressure that the liquid is under. For a substance, it is a constant temperature. The constant temperature points of melting, freezing, and boiling can vary as the atmospheric pressure changes. Physical changes. Changes which involve only a change in the physical properties like size, shape, form, and state of a material, but where no new substance is formed are called physical changes. Physical changes can be reversible or irreversible. Example, changing of ice into water is reversible change. On the other hand, the breaking of a glass bottle is a physical but irreversible change. A very large number of changes in matter are more permanent. It happens when the atoms within a molecule are altered by a decrease or increase in number. It can also happen by rearrangement of atoms within a molecule. Chemical changes. In all these activities, we have seen that new substances are formed. The changes which involve the formation of a new substance are called chemical changes. Such changes are permanent and cannot be easily reversed. The atoms in molecules of these substances break their links or bonds with each other. They rearrange their atoms and form new links or bonds with atoms. The result is formation of one or more new substances with different chemical features and properties as compared to the original substances.
Examples of formation of new substances are burning a piece of paper to form ash, formation of curd from milk, putrefaction of food leading to its spoilage, germination of seeds into seedlings.
Differences between physical change and chemical change. Types of chemical reactions. 1. Synthesizes reaction gain in matter. This reaction occurs when two or more substances react to produce one substance which is always a compound. These types of reactions may be brought about with the help of heat, light, or electrical energies. 2. Decomposition reaction. Loss of matter. This is a chemical reaction in which one single compound is broken into two or more simple substances, elements or compounds. They generally require the application of energy to the molecule from outside, and so these are mainly endothermic reactions. 3. Displacement reaction. Matter replaced. In this reaction, one element displaces another element from a compound and takes its place. As in the example, a more reactive element displaces a less reactive element from a compound in solution form. The element placed higher in the activity series of metals can displace the element placed below it from a solution of its compound. 4. Double decomposition reaction. Exchange of matter. In this kind of reaction, the constituents of two compounds mutually exchange their radicals to form two different compounds. The neutralization reaction you studied in acids, bases, and salts chapter fall in this category. Rusting of iron. Iron is one of the most popularly used metal on earth. It is used in the making of cars, trucks, ships, bridges, gates, furniture, and many other articles. Rusting of iron is a slow oxidation process in which iron reacts with oxygen present in the air in the presence of moisture to form a substance called iron oxide, which is commonly known as rust. Rusting causes a huge monetary loss and damage. The layer of rust so formed corrodes the iron and gradually falls off, thus exposing the fresh metal, which again gets rusted. This continued rusting makes the iron object weak. Oxygen and moisture are two essential conditions for rusting. Rusting is faster when moisture content in air is high. Fe plus O2 plus H2O gives Fe2O3. Rusting is a continuous, irreversible and wasteful process and should be prevented. Rusting of iron is an electrochemical process which requires the presence of water, oxygen and an electrolyte. Relative humidity of over 50% is sufficient for rusting to occur. Water becomes an electrolyte by mixing one or all of the ingredients present in atmosphere such as carbon dioxide, salt in coastal areas, sulfur in urban areas or other pollutants. A. If oxygen is in deficient quantity, Fe plus H2O gives FeOH2 is formed. This forms a coating on the iron surface which actually prevents further rusting as happens inside engines. B. If both water and oxygen are adequately available, Fe2O3 H2O, the reddish-brown rust is formed. The rusting process begins with oxidation of iron. Fe gives Fe double positive plus 2E negative. Fe gives Fe triple positive plus 3E negative. And once electrons are released, electrolysis is triggered with clear-cut cathodic and anodic ends. Ways of delaying or preventing rusting. Why does exposed surface of a cut brinjal become black? When a brinjal is cut, the iron-containing chemicals in the brinjal react with oxygen in the air. The enzyme that regulates oxidation is polyphenol oxidase, PPO, also known as tyrosinase, and turns black. The same reaction occurs in many cut fruits like apples, banana, etc. The oxidation can be prevented by coating the cut surface with lemon juice or even sugar solution or boiling the cut fruit. Bruised brinjal or apples but intact from outside also show oxidation, as when the brinjal is dropped many cells get damaged and its content flow within the fruit, which reacts with air inside the brinjal and turns black. Brinjals have over 25% air content, that is why they float in water. This blackening of fruit is a chemical change.
Some PPO reactions are desirable, such as the brown color of tea, coffee.
Crystallization. Crystals are perhaps purest form of substance with a geometrical shape as atoms or molecules are arranged in a particular regular pattern. The process of formation of large crystals of pure substances from their saturated solutions is called crystallization. The crystallization process has two steps. A. Nucleation, when the solute molecules in the solvent gather to form clusters. The clusters then stabilizes at a particular temperature and pressure. B. Crystal growth. The atoms begin to arrange in definite periodic manner on the cluster that gives the crystal its structure.
Crystals precipitate from a saturated solution, as in case of copper sulfate, or directly from vapor state, as in case of naphthalene, because of sublimation.
Why is seawater salty? The seawater is a complex mixture of a variety of salts, the principal source of which have been A. Decaying organic matter that comes from the abundant life in the sea and oceans. B. The gradual process of erosion and weathering of igneous rocks all over the earth's surface that have been carried to the seas and oceans. C. Dissolving of salts from the ocean floors and volcanic eruption under the sea over a period of millions of years. Further, over a period of the life of the earth, the sea and ocean keep getting concentrated with salt by the hydrologic cycle. The most common salt in seawater is sodium chloride. It forms 3.5% of seawater by weight. Dead Sea. It is 1385 feet below sea level between Israel and West Bank. It has 33.7% salinity and it does not support any living organism except some bacteria and fungi. Salt can be separated from seawater. Through the ages, in coastal areas, salt is made by the villagers. A. First, they trap seawater during the high tide in low-lying areas. B. The hot sun gradually concentrates the water by evaporation and finally over a period of few weeks, salt is obtained. This salt is called sea salt or sun salt and may not be pure enough to consume and needs refining.